So let's talk a little bit about what we're trying to do when you dig or plow the soil. You're trying to create a situation that soil scientists call, you're trying to create a soil that has good tilth. And tilth is actually a term that's indicative of a whole lot of technical terms, but what it really means is how easily is your soil worked up and amenable to grow plants. You do this by frequently adding organic matter. You should add organic matter at least once a year, and for all practical purposes, you add organic matter pretty much every time. You take a crop out and you turn the soil and you plant again. Organic matter is eventually, by organic matter I mean either in the form of a green manure that rots down and then you plant into it, or finished compost that you can plant right into. Organic matter is a source of nutrients for plant growth, and or maybe more importantly, organic matter is a feedstock, as they say now, for the microbial life in your soil. Not exclusively, but principally bacteria and fungi, beneficial ones, that will break down this organic matter, render it up into a form that can be dissolved into water, as I said, and make it available to plants. One second. The other thing about a beneficial microbial life in the soil, and more as time goes on, that's what I'm trying to do, is foster a microbial population of bacteria, fungi, and there's these other critters that are kind of conflicted. They're called actinomycetes, and their cells are like bacteria, but they have hyphae like fungi. They're conflicted, like I said. They do some of what both those critters do. You're trying to foster a population of these microbes in the soil that will help break down organic matter and render it up as plant food, but also they exert an extremely positive effect on pathogenic bacteria and fungi that are in the soil. So you could just kind of say, you know, good guys and bad guys. And it's actually much more technical than that. But these beneficial bacteria that and fungi that you're trying to foster, some of them are actually predators. I have these great color photographs, electron microscope probably, of the hyphae of a fungi lassoing a nematode and garroting it like that. That's really cool. And the other way that these beneficial critters, as it were, suppress pathogens is simply by occupying space. They get the niche, they get the physical space, they get the air, they get the water, they get the food. So when you're working the soil, you're trying to create this thing called good tilth or good structure. If you look at a soil and you pick up a handful of soil, and it's ideally, this is what the makeup of a handful of soil is. Only about this section over here, which would be 45%, is the mineral component of the soil, the stuff, the bulk of the soil. That which used to be rocks millennia ago, think of it as rock flour, rock dust. It's of mineral rock origin, and then you might have, if you're lucky, 5% organic matter. This is the result of things that used to be alive, plants, manures, etc., compost. And then, so I got a handful of soil. Only half of it is, this is the solid component of the soil, mineral and organic matter. In an idealized soil, half of that handful of soil is pore space or air space. And very much what you're trying to do with your digging and plowing is create this idealized scenario. In the idealized soil, at the idealized point in time where plants will actually grow, that pore space or air space is occupied about half of that by, I put O2 here, it's air, it's O2 that we're concerned about in the air mostly, and water. So this is a physical setup in your soil. In a handful of soil, a mass of soil, half of it is solid matter. 45% approximately that is of rock origin, mineral origin, rock dust, rock powder. I like that image. 5% is organic matter. It used to be alive, plants, microanimals, manures, things like that. But you're trying to create a situation where you have a continuous run of pores, space, the air space in the soil, that runs from the surface down to the subsoil. And what you want is macropores, or big pores. Plants' roots don't actually grow in the soil. They grow in that interstitial spaces, the pore spaces, the channels between solid material in the soil. And plants' roots, their growth is fueled by oxygen. So the more pore space you have in your soil, the greater the aerobic capacity, the greater the air, the greater the oxygen in the soil. The other component of the biological soil community that needs oxygen for their metabolism are these microbial critters that I mentioned. So you're trying to create a situation that is physically easy for the roots to push through. To a certain extent, the bigger and the more continuous your pore space, the less caloric energy these roots have to use to move, probe, draw in water and nutrients, and they grow better for you like that. But you're also very much trying to create, with that situation, a hospitable environment for microbial life that in turn helps to break down organic matter and grow the plants.